Assalamu alaikum wa rahmatullah. Today we will discuss the first law of thermodynamic. إذا راح نبدأ في البارت الثالث وهي قوانين الديناميكا الحرارية. في المحاضرات السابقة وضحنا القانون الزيرو لو اوف ثيرمودايناميك، ومن ثم تحدثنا عن الايديال جاز والريال جاز. Okay, the first law of thermodynamic is an extension of the law of conservation of energy. إذن هو عبارة عن conservation of energy. So the change in internal energy of a system is equal to the difference between heat added to the system and the work done by the system. إذن هي عبارة عن ال change of internal energy delta U. So and the difference between heat added to the system and work done by the system. So the internal energy of the system can be changing by doing work on it or by heating or cooling it. So from the microscopic point of view, this statement is equivalent to a statement of conservation of energy. إذا هي تكافئ اللي هي قانون حفظ الطاقة. فإذا كان عندي أنا state 1 وفي عندي أنا غاز وفي عندي بستون، فبالتالي we have heat transfer to state 2. If we doing work may compress to the gas, then state 2 it's compressed, so we have heat transfer Q, and also we doing work on it. So U is internal energy, and U or delta U تساوي U2 minus U1، and delta U U2 هي عبارة عن heat transfer and U1 هي عبارة عن الwork. So note, the first law of thermodynamics tell us that in order to change the internal energy of a system, we must add or remove heat and or do work on or have work done by. So this is two important statements: do work on or work done by the system. So, or we can say that change in internal energy equal energy supplied to system as a heat على شكل حرارة plus energy supplied to system as work. إذن energy as a heat زائد energy as a work. So delta U, this is the change in internal energy. Delta U تساوي Q heat plus work. This is U, the internal energy, like reservoirs of the bank. إذا مثل ما حجزت في البنك. البنك accept deposits or withdrawal into currency. يعني بنك في عدة أنواع من العملات اللي هي عبارة مثلا شيكل دينار، فهي عبارة عن إيش؟ كيو هاي الكرنسيز، كيو زائد الورك، but stores them هاي بنخزنها as common فند. احنا بكون عندنا فلوس في البنك. هاي الستورز عبارة عن الانرجي، internal يو internal energy. Okay, so we have this system U, and we have energy supplied as a heat اللي هي Q, and also a change also supplied work. So delta U is change in internal energy. والوحدة بما إنها energy، إذا الوحدة راح تكون عبارة عن جول. أما Q هي heat added or lost. يا إما بنضيف يا إما السيستم it's lost by the system and it's also in joule. and الwork يا إما الwork done on or work done by the system. إذا يا إما الwork done on the system نعمل على السيستم أو السيستم or work done by the system. من نفس السيستم بيعمل لنا إيش الwork. And this is a pen, this is you. Here we have this Q and work. أو إنه ممكن إيش يكون عندي lost of Q أو or work done by the system. Okay. إذا statement of energy conservation of a thermodynamic system in general, heat and work are forms of energy transfer and energy is conserved. So delta U equal Q plus work on. Look here, work on, work done on the system. And this is heat added to the system. And delta U is change total energy state as a function, or delta U equal Q, and this is minus work by, إذا done by the system. إذا بدنا ننتبه، إذا كان عندي work done on the system فالwork راح يكون positive. أما إذا كان الwork done by the system راح يكون عندي إيش negative. So the inner energy of the system tends to increase if energy is added via heat. إذا راح تزيد إذا إحنا عملنا added بواسطة الحرارة or decrease via work done by the system. done by the system إذا راح يكون إيش ناقص negative لأنها done by the system. إذا this is two statements done by or work done on. It's important in the first law of thermodynamic. Also the heat, it's important if we add it or lose. So this side on Q and work depend on the way the internal energy is changed. If Q and work are positive, the internal energy, of course, it will be increase. But if Q and work are negative, the internal energy decreases. Okay, from the first law of thermodynamic, أنه الانرجي is conserved. So delta U هي عبارة عن U final minus U initial، وهي تساوي عبارة عن Q minus الwork. إذا بهاي الحالة Q heat absorbed by the system from the surrounding. أما W is work done by the system on surrounding. إذا ننتبه للمعاني Q and work, okay, in this equation. So heat is random molecular motion, while work is force, time, distance moved under its influence. إذا الهيت هي عبارة عن الراندوم موشن للجزيئات، بينما الورك هي عبارة عن الفورس مضروبة في إيش؟ في المسافة. لأن الورك بنعرف الميكانيكس هي عبارة عن F times delta X. So we have exothermic process. هذا يعني إنه release heat and have a Q أقل من زيرو. إذا it's negative. أما endothermic process absorb heat and have a Q is positive, greater than zero. So the energy, the SI unit is joule. Although we will frequency used calories. إذا 1 calorie بيساوي 4.2 جول or 1 كيلو calorie equal 4.2 kilojoule. So the work is not necessarily associated with the volume change. Example, in Joule experiment on determining mechanical equivalent of heat, the system water was heated by stirring. إذا بنحرك الووتر والسيستم إيه؟ عم نرفع درجة حرارته نتيجة إيش؟ الستيرنج. And then we have the special cases of the first law of thermodynamic. إذا isolated system. إذا كان السيستم معزول هذا يعني the system doesn't interact with the environment. عندنا عزل، إذا ما في السيستم ما راح يتفاعل مع المحيط أو surrounding. So what does this mean in terms of the first law of thermodynamic? هذا يعني إنه Q equals zero. No heat is transferred into or out of the system. ما في لا حرارة بتدخل ولا بتخرج. أيضا الwork equals zero. No work is done on the system. هذا يعني نرجع للمعادلة دلتا U equal Q plus work. Q is zero and the work is also zero. So delta U equal zero. هذا يعني إنه U initial equal U final. Initial energy تساوي final energy. In cyclic process, if we have a cyclic process, this means the system starts and end in the same state, same internal energy. So the system is not necessarily isolated. The function that describes the change in state on PV diagram would be a closed curve. Then this is a cycle. This is a closed curve. هذا يعني delta U equals zero. No net change in internal energy. Delta U equal Q plus work. And in this case, in cyclic process, delta U equals zero. This means Q equal minus work. And another application of the first law of thermodynamic, adiabatic process. What means by adiabatic process? أول شيء adiabatic process هي كلمة لاتينية مقسمة إلى 3 أقسام: adiabatic not go through not go through. إذا هي الأدياباتيك بروسيس. أدياباتيك هي كلمة لاتينية معناها not go through. So this is process. إذا physically ما معناها physically هسا. This process consider a system where there is no lose or gain of energy through heat. إذا لا بيفقد ولا بيعطي energy خلال درجة الحرارة. And this is can be accomplished by thermally insulating the chamber. إذا بنعمل insulating the chamber and perform the process very rapidly. إذا بنعمل العملية بشكل سريع. So no time for heat to be transferred. إذا ما في وقت، إذا هي rapidly تكون العملية سريعة بحيث إنه ما في وقت حتى تنتقل الحرارة. And this is delta U equal Q زائد الwork. بما إنه ما no time for heat to be transferred, this means in adiabatic process Q equals 0 and delta U, the change of internal energy, equal the work. We have some example. If we make expansion of hot gases in internal combustion engine بالمحرك أو liquefaction of gas in a cooling system. And we have another application in adiabatic free expansion. Adiabatic free expansions, this means this is a special case of an adiabatic process where the gas expand into free space. هذا يعني دلتا يو تساوي كيو زائد الورك، لكن Q equals 0 and also the work equal 0. This means in adiabatic free expansion, the internal energy is equal 0. So if we do work to compress the gas, the temperature of gas should increase. The increase in temperature of the gas corresponds to an increase in the internal energy of the system. Okay. Another application is isobaric process. What do you mean by isobaric process? It's constant pressure process. This means delta U equal Q زائد the work, and in isobaric process Q equals 0 and also the work equals 0. So the work even in isobaric process, sorry, Q it's لا تساوي 0 and the work تساوي 0. So راح تساوي الورك راح تساوي الكيو أو كيو راح تساوي الورك، والورك بيساوي ماينس بريشر في في فاينل ماينس في initial. إذا ماينس بي مضروبة في دلتا في. Another process isovolumetric or process or isochoric process. إذا أحيانا المصطلح بنستخدم isovolumetric or isochoric process. This is constant volume process. إذا isobaric, it's constant pressure. Isovolumetric or isochoric process, constant volume process. This means delta U equal Q زائد الwork, and in this case Q لا تساوي 0 لكن الwork بيساوي 0. If the volume doesn't change, the work cannot be done to compress the gas. This in isovolumetric a process delta U equal heat. Okay. Another process is isothermal process. In isothermal process, constant temperature process. This means delta U, okay, equal Q plus the work. And delta U in this case equals 0 and Q equal minus the work. If you do work to compress a gas energy, you put in is raised through heat. إذا راح يتحرر نتيجة تدخل الحرارة. On a PV diagram, it is common to use isotherms to show how the temperature change for the process. إذا isotherm hyperbolic line of constant temperature راح يكون in PV diagram. إذا لازم ننتبه في isothermal process is a constant temperature. إذا work in thermodynamic, we have a state previously pressure, temperature, and volume are considered state variable and are used to define the particular state of the system اللي هي BVT. Then work and heat are called transfer variable. These describe change in the state. They don't describe the state. We know how to describe the work done on the system. For example, let us look to applying force to piston in order to compress the gas inside container. Then we have this ideal gas and we have a container and also we have piston. So if we apply force, what's happened? It will compress the gas and it will be change distance اللي هي delta y. Okay, this we compress the gas. Then we have from here is delta y. طيب. And this is the area. So, and this is also the delta V. Then we create the area and we have also التغير الحجمي. لكن بنعرف انه الورك بتساوي minus F في دلتا واي. ولكن ايضا نعرف انه البريشر equal الفورس على الاريا. This means the force equal the pressure مضروبة في الاريا and the work نعوض F but في الwork this means the work equal minus B the pressure في الاريا في دلتا y and نعرف انه A في دلتا y this is the area and this is delta y. So delta v هي عبارة عن ايش؟ A الاريا مضروبة في دلتا y. فالنتيجة الورك تساوي minus B في دلتا v. Okay. So during a compression work done on gas, it's positive. So work equal minus B delta v. So this is the end of this lecture and we will continue next lecture. Thank you for your attention.